We have to deal with more than one solution. There's not just one solution. The good thing is the solutions mostly obey straightforward rules. We know there's only a countable number of solutions because that's what we've seen. When we shine light on atoms, we only see certain levels occupied. Each of those levels corresponds to a solution to Schrodinger's equation for an electron around a hydrogen atom. So in quantum mechanics, the mathematical solutions of the wave equations, i.e. Orbitals, we're starting to use atom descriptions now, not math descriptions, can be classified by 3 sets of discrete numbers. They're just integers. They give information about the region that the electron is likely to be in and the energies of it. So the name of these quantum numbers, the principal quantum number n, which gives information about the orbital size and is the major determinant of the energy of that orbital. The angular momentum, we label that by L, and that's the 3D orbital shape. And the magnetic quantum number, which gives the orbital orientation about the x, y, and z axes. Other words you can use, the principal quantum number n is also called the shell. The angular momentum is sometimes called the subshell, and the magnetic is sometimes called the orbital. So shell, subshell, and orbital are just ways of saying electrons that have certain principal quantum numbers, angular momentum quantum numbers, and magnetic quantum numbers. So relationship between orbitals and quantum mechanical numbers, the quantum numbers, and then these orbitals start to feel like things you've seen before. 1s, 2s, 2p, these are exactly the things you've seen in chemistry classes before. So if we're at the first principal quantum number, there's only one possible angular momentum quantum number and only one orbital. So there's only one solution for principal quantum number 1, and that is the 1s orbital. There's only one orbital in the subshell and only one orbital in the shell. If n equals 2, then L actually has 2 possible values. And if L is 0, M, the magnetic quantum number, also has to be 0. But if the angular momentum quantum number is 1, then -1, 0, and +1 are all possibles. So those are the 2s, if 2 for the principal quantum number and s for the orbital quantum number, and 2p is the other possibility if the orbital quantum number is, if the angular momentum quantum number is 1. ML is the orbital. So there's 1 orbital in the 2s subshell and 3 orbitals in the 2p subshell for a total of 4 total orbitals. The patterns continue like that. What you see is that L has to be less than n, and L is always greater than 0. ML, the absolute value of ML is less than or equal to L. So if L is 1, ML can be -1, 0, +1. And then, so those are the rules that we have to follow. Again, these are the different types of solution that come out of Schrodinger's equation. Okay.